Hello and welcome to another episode of Mrs. Technically Speaking, and today I'll be dealing with organic chemistry, specifically focusing on the addition reactions of alkenes. So let's look at all the definitions of the reactions because the definitions will give us greater understanding in how things work. So we are definitely going to focus on addition reactions of alkenes. Now, an addition reaction is defined as a reaction in which the double bond in the starting material is broken and elements are added to it. So this video focuses on alkenes, which are perfect because they have a double bond which will be broken where elements are going to be added to it. We have many other reactions as well for alkenes. But all of the reactions for alkenes are going to take the nature of addition because there is a double bond that can be broken. So let's look at what are those reactions and what are the elements that we are going to add. So if we speak about number one, halogenation, it means that we are adding a halogen, BrClFi, with a compound, and that compound is going to be our alkene. Hydration, we are going to add water to alkene. Hydrogenation, we are going to add hydrogen to an alkene. Hydrohalogenation, we are going to add a hydrogen halide to an alkene. Hydrogen halide taking the form of HX, where X is any halogen. Halogens are group 17 of the periodic table, which will be Br, Cl, F, and iodine, fluorine and iodine. Then there is hydrolysis, which is the reaction of a compound with water. But we are speaking about alkene, so we are going to add water to an alkene. Let's start. Addition reaction is a reaction in which a double bond in the starting material is broken and elements are added to it. So we are speaking about alkenes. Alkenes have this double bond which will be broken up. So this has hydrogen and hydrogen. That double bond will now be broken up, right? And elements will be added to it. So what will happen is this double bond over here will be broken up, and then you can add two elements here. So let me do it like this. Addition of elements. And that is by definition. Elements are added to it. Okay. Let's look at an example. Number one. If we add hydrogen to ethene, then we will have hydrogen plus the alkene. So here we are adding hydrogen, which is H2. It's a gas. Then what will happen is there where it opens up, the hydrogens are going to be added. So these hydrogens that I'm drawing here are already there. They're already those. This is C2H4, right? Plus H2. Now we are adding in those hydrogens into the alkene. So those hydrogens that I'm adding, these ones here, they are adding there. And then we are getting C2, 1, 2, 3, 4, 5, 6, H6. So this added in, everything was added to give us a total of H6. And because we're adding hydrogen, it is hydrogenation. Okay? So this is just a basic starting example of how we add in everything to an alkene because an alkene is unsaturated. Unsaturated means there's a presence of a double bond which can be broken up, and then this alkane is saturated. So addition reaction will be the cause of going from unsaturated to saturated. Now remember, I'm revising again, addition reaction, a reaction in which a double bond in the starting material is broken and elements are added to it. Which is the double bond? Alkene. So let's start. We have an alkene, and we already in the previous slide we said there are 4 reactions that we are going to speak about. So the first one, number 1, is going to be hydrogenation, which means that I am adding hydrogen. The next one that I'm going to talk about is the addition of water, which is going to be hydration. The third one I'm going to speak about is halogenation. And the fourth one that I'm going to speak about is hydrohalogenation. And here we are going to have with 1 halogen, and then I'll make an example with 2 halogens. All right. Now let's get started. If we have an alkene and we add hydrogen to it, hydrogen we are adding 2 H's. Then it is going to be alkene will form an alkane, which we saw when we started in the previous slide. When we add H2O, what is going to happen is this water molecule is going to break in 2, and the OH, which is your hydroxyl group, will form on 1 carbon, and the hydrogen will go on the other carbon. So because water is adding in a hydroxyl group, when you add water to alkane, hydroxyl is alcohol, so you're going to form alcohols. Halogenation means we are adding only halogens, and specifically 2 halogens, for example Br2Cl2, because we know that gases are diatomic. Di means 2, so they do not exist alone. There must be 2 of them. So halogenation would mean that I'm going to form what? I'm going to form a haloalkane. And this haloalkane that's going to be formed will have 2 halogens, right? 2 halogens. So it will take the form of something, comma, something, di, chloro, bromo, whatever, and then the alkane part. Hydrohalogenation is going to add a hydrogen and a halogen, so it's going to be the haloalkane with 1 halogen, because you're adding HX. So what's going to happen is the hydrogen will go on 1 carbon and the halogen will go on the other carbon. So you're also going to form a haloalkane, but this haloalkane will only have 1 halogen. So it will take the form of something. Let's do example 1, bromo pentane. Unlike here, when you're adding 2 halogens, it will be 1, 2 dichloro propane. You see, these numbers means 1 chloro is on carbon number 1 and 1 chloro is on carbon number 2. Here, because you've added hydrogen and you've added, actually it will be 2 bromo pentane, right? So here 1 hydrogen will go on the first carbon and the halogen will go on the second carbon. And I'll speak about the rule of hydrogens that is determining on which carbon it will join. All right. Right, so let's now move on into these examples on an individual basis. Right, so let's start with the first one, right? The first one was hydrogenation. In hydrogenation, we are saying that we are adding hydrogen. And hydrogen is a diatomic gas, so it will be H2 that we are adding. So if we have, this is carbon 1, 2, 3, 1, 2, 1, 2, 3, so we add one more, 1, 2, 3. So this is prop 1ene. Propene is still fine, but let's get used to the numbers. So now when we add our hydrogen to it, the double bond is going to break, and this hydrogen is going to form there, and the other one is going to go here. So we are going to have one here and one here. So once again, what happened? To propene, we added hydrogen in hydrogenation, and it formed propane. So it's an alkene plus hydrogen will always give you an alkane. Let's move on now to the second one. The second one was hydration. In hydration, we are adding water, H2O. We also know that this structure is going to divide in two, such that the OH joins on one carbon and the hydrogen bonds on another carbon. So let's first take this as an example, which is ethene. And then I will do a second example to bring in now the rules of hydrogen. So that we can see what happened. So if we add water to an alkene, we are going to get alcohol. So let's see now, we are adding in the water, H2O plus H2O. So there's going to be this part, which is going to be our hydroxyl part, right? This is the functional group, hydroxyl. This is going to form the hydroxyl group, which is for alcohols. So here it's very easy because both of these carbons have the same number of hydrogen. You can add it to any one of them. So what is going to happen? This is already there. This is C2H4. It's already there. Plus H2O. It's already there. Now, the OH can be added there. Now we have 1, 2, 3, 4, 1, 2, 3, 4, 5 OH. So that is alcohol. But when you have more carbons, all carbons don't have the same number of hydrogens, you have to consider the number of hydrogens in order to add the hydrogen part and the hydroxyl part. Now, if we look at carbon number 1 and carbon number 2, you'll agree with me that carbon 2 has 1 hydrogen and carbon number 1 has 2 hydrogen. Now the hydrogen from water must be bonded to the carbon with the most number of hydrogens. So what must happen here is that on carbon number 1, the extra hydrogen must form, right? So let me draw what is already there. Okay, and this one is at the top. And that is how the molecule looks already. Now when we are adding in the water part, the rule says the hydrogen must go to the carbon with the most number of hydrogen. So it can't be this one because it's already saturated. 1, 2, 3, 4. It can't be carbon number 1 on this side. But we start counting from here because the double bond was there initially. So the hydrogen must form on here because this one has 2 hydrogen. This one has 1 hydrogen. So your alcohol part, your hydroxyl part must form here. So here the general formula, it will be, or the general equation, alkene plus water is going to give you an alcohol. And your alcohol will be on the second carbon where the double bond is, not on the first one. Right, let's move on. The next part that we were talking about is the third equation, which is halogenation. Halogenation, we are adding a halogen, and this means we are adding X2, which will be Br2, fluorine, iodine, or chlorine, right? So again, we have our alkene plus a halogen in the form of X2 is going to give us a haloalkane. And this haloalkane is going to contain 2 halogens because whatever you react with, everything is going to be added to the alkene. So let's go now for prop1ene. And to it we will add, let me change colors, Br2, right? And then what are we going to form? Here is the original part of the molecule, the starting part. And actually, I have the hydrogen on the top, so let's put it on the top. So here is what we have. Now, can you see these lines that are empty? That is where our bromine is going to form because it is where the double bond broke, okay? So here will come one Br and there will have the other Br. Where did I get it from? I got it from the halogen from halogenation. So here I have prop 1ene plus bromine gas is giving me 1,2 dibromo 1,2,3 propane. The number of carbons must always stay the same, right? Because we are not adding carbons, we are adding in substituent groups like halogens, or we are adding in hydrogen. So the number of carbons always remain the same no matter which reaction we have. So the general equation is an alkene plus a halogen will give you a haloalkane that has 2 halogens, taking the form of a number, 2 numbers, di, your halogen, and then the parent, which is propane, butane. It really doesn't matter. Right, then the next one, number 4, we said it is hydrohalogenation. So hydrohalogenation means we're adding hydrogen and we're adding 1 halogen only. So this could be, for example, HCl, HF, HBr, right? These are most popular. So this is the addition of hydrochloric acid. This is the addition of hydrogen fluoride. And this is hydrogen bromide. Right. So when we have an alkene, we add a hydrogen halide. We are going to get a haloalkane that has one halogen. Alright, so let's see. 1,2-ethene. We can do a second example. Let me do bute. Right, so this one will have 3 carbons. 1, 2, 3, so one more. 1, 2, 3, so one more. 1, 2, 3, 4. Every carbon must have 4 lines around it. So here let us add different kinds. Let's go for adding hydrochloric acid and adding hydrogen bromide. Now here, these carbons have equal number of hydrogens, so it can go on any one, right? But here it's different. It's not like prop 1-ene. Also here they have the same number of hydrogens, so it can go on any one of them, right? So let's draw our existing molecule. This is what is already there. And this is what is already there. Right, now what are we adding in? We're adding in hydrogen chloride, so hydrogen and chloride. Here we are adding H and Br. So what is the name of this? This is carbon 1, 2 and carbon 1, 2, because your homologous series must always have the smallest possible number. So if I count it from here, it would be 3, so I have to count from that side because it's 2 is smaller. So this will be 1-chloroethane, Eth2. Position of chlorine or chloro is 1. Here it is 2-bromo, 1, 2, 3, 4, butane. And those are the reactions.